Okay, we are live. Welcome everybody to yet another stream of mine. This is my third. Let me just verify that everything is working as it should be. Can you hear the sound okay? If so, please write in the chat. Can you hear me okay? Okay, thank you Arnav. And hello Ansul, welcome to the stream. For you who don't know, Arnab is my dear moderator. So he'll be looking after the chat today. We will soon be starting with the actual coding. I will only take a couple of minutes to talk to you guys a little bit and let other people join as well, because there's always a couple of latecomers, so I don't want to start coding right away and they will possibly miss the first part. Hello Angel, how are you my friend? And hello Hezekiah, I'm sorry about the pronunciation. Okay, hello Mr. 21. Yes, and we are not just doing Redis, we are coding our own Redis. And hopefully it'll be faster than Redis. So I can take... and hello Imoris, welcome to the stream. I can take a little bit of... I can tell you a little bit of information about the project that we are going to do. So let me show you what I stumbled upon. I was checking out the Redis. For you who don't know, Redis is an in-memory cache database. Probably the most used in-cache database in the world. So I went on to this webpage and I found something, let's see, this one. Get the world's fastest in-memory database from the ones who built it. And I thought to myself, well, what if we can do better? What if we can build the fastest in-memory database in the world and force Redis to change their homepage and write something like, get the world's second fastest in-memory database? Wouldn't that be kinda nice, everyone? So that's a general idea. And my thought is we're gonna build this on a binary tree, and we're gonna optimize it using our own implementation of a hash table. So that's basically what we're going to do today. We have, I think a lot of you have seen that episode where we build a binary tree. So we will finish that binary tree and integrate it into our database, and then we will try to optimize it, and we will do some testing to see how many collisions and stuff. I will talk more about how that works a little bit later. Let's see. Hello Coffee, welcome to the stream. And hello Zuzu. That's right, Coffee. We have a new moderator. And so yeah, that's basically the general idea. And I think we should get started. I'm planning to do about 3 hours, but we will have a 20-minute break somewhere in the middle. So that's basically it. Sounds good, 21B. And hello, Dheeraj. Ready? Good that you're not missing this stream, and welcome to this stream. I hope you will find it interesting. I think the topic is very good today, and I think we can do something really interesting with it. Anyhow, I will move over this chat for a little bit, and I need to log in to my system, my dear CodePlanet server. So let's see, let's do a new screen. And for those of you who don't know what Screen is, it's one of my favorite Linux programs actually. It makes it possible for me to I can do like create a window like this and toggle between really fast with a key combination, and if I get disconnected from the server, it will look exactly the same when I reconnect. So the screen is alive when I'm not logged in. And Screen is a standard tool in almost every Linux distribution. Yes, so let's see. There are two projects. So we have this. Let's see. We have the tree. This is the binary tree. Let me just show you a little bit about it. We are going to code in VS Code today, but I can show you faster in Vim. So let's see. So this is what we have done this far with the tree implementation. Basically, we have two different kinds of structures. We have nodes, which connect to other parts of the tree, and we have the leaves, which contains the actual data. So every node becomes a level or a folder, so to speak. So basically, we can have like the root as the first one, and then maybe we have one folder for the users, and then we can have a lot of the leaves inside of these folders. So we can have like users and login or something like that. And the general thought is that when we search in the optimized version of the algorithm or whatever we should call it, then it should be able to find stuff in every folder without having to go through the entire structure every time. So that's the idea. And there's only a couple of functions in this. We have a zero function that just puts 0 in a variable or part of the memory. We have a create node, which creates a node, so a folder. We have a function for find last, and when I do these kinds of functions, I usually call it something like find last, and then I add a suffix. So this is the linear version, and later, and I use like an alias a macro which called just find last. So from the beginning I point that to this function, but then when I create a more optimized version, then I can just point the alias, and I won't have to alter a lot of different parts of the code when I want to use the other function. And then we can create a leaf with this one, and then we have the main. And we will not have any main in this part of the code when we are done, because this is going to be more like a library. But it's good to have this when we are experimenting and double checking that everything works and so. So this is the tree implementation. We're gonna keep building a little bit on that. And then we have the actual server. It's called Cache 22. So this is where all the server stuff happens, the network connection and all that. So what we did last time is we set up all the different networking stuff. So we prepare it to listen for a TCP port, and when we do get a connection, it will let's see what we did. Yeah, it will fork and create a new sub-process, and that sub-process will run this looping function, which doesn't do much at the moment, but we will put so it will listen to the commands that we send to the server. So this is a lot of boilerplate stuff mostly at the moment, but my hope is that we will finish this part of the program today, and we will have at least a linear implementation of the search algorithm, and possibly more than that. And I will do another stream if well, I will do another stream anyhow, but it will probably be one more session with this project. And for you who well, those who's not listening today and it's not here watching live, will get a second chance when I publish the recording on Sunday. And I will also create a reference file. So if we do go to any web pages where we get any information or stuff like that, I can write down the link, and afterwards I will put this in the description of the recording when I release it. So that's basically what we are going to do today. So what do you think about that chat? Do you think it will be an interesting project, perhaps? Great. All right then, let's get started. So I will, as usual, go into this and set my home directory to this directory, so it's a little bit easier to handle. And it's not only because I want to have a small prompt. It's also if we have like a couple of subdirectories, like this, and maybe one more even, like this, and I go in there and I do stuff, then I can just do CD to get back, and it will not fill the entire screen every time because of the path being too long. So it's quite nifty. Alright, I will start by copying over the tree implementation to this directory. So I will do something like this. I will go to the tree and I will copy star dot. I want the C files and the H files, and I want them in here. So there we go. I will also need to update the make file, but let's do that part inside of VS Code instead. So I will go into my Sociopath client and find my cache 22 folder, and then I will just open it in editor. And perhaps I should include that link to this program as well, in case you are also like me coding on an external Linux virtual private server or similar. So let me just see, it's www.birch.com and Sociopath. So this is the page, and it works for Mac and it works for Windows. So I will save this link and put it inside of this reference. So Sociopath Scp Clienr remote edit your code like so, and let's see where my VS Code went. I need to make it a little bit smaller so it should fit on the screen. Something like, I think we can do like this actually. Like so. I hope the text is big enough for you. On small screens it might be problematic sometimes. Alright, so let's open all of these files. And didn't get the make file, so let's do like this. The reason it didn't get the make file, by the way, is because you configure the SCP client by telling it what kind of file extensions you want to use. So I have configured it for .h files and .c files, etc., but not for the make file, so that's why. But that's easy to fix. You just edit the configuration file. It's quite self-explanatory. Alright, so we need to add the tree implementation as well. So what do we have? We have a tree, or we want a tree.o, and it's coming from tree.c. We want to run cc with our flags, and then we will have -c and the source file. So this is for the source file. When we have an O file, we can compile the actual tree binary, and we need the tree.o as a dependency, and then we will run cc with our flags, and we will have the source file -o and the target, and possibly some LD flags as well for the linking. And we'll do clean catch22. Let's do tree in between here, like so. And so now I should be able to do make tree. Okay, it didn't really like my spaces instead of tabs, probably due to the copy pasting from the terminal. So let's see. Let's do all of these. And this one as well as this. Okay. So let's try it again. Make tree. Yes, it compiled. And here we have our tree. So we haven't yet coded a function to display the tree. So what we are displaying at the moment is a value from one of the leaves, and the addresses of I think it is the leaf and the node, if I remember correctly. But everything works this far. And by the way, if you have any questions, I will not be able to see it in the chat when I am coding, but Arnab will take care of the questions, but save them, so when I ask him later on, are there any questions, he can give me one at a time. So he's keeping track of all the questions. Great. So let's see where we will start. Let's also compile the rest, by the way, so we see that everything is still working and I haven't been editing any stuff. So as you can see, it is listening on this port number 12049, and the actual port number was decided by you guys last time, but you can specify the port. I think we did it like this, right? Yeah, you can specify it directly on the command line, and you can also just edit a constant definition inside of the H file. Okay, so everything is up and running, and let me show you what happens when you connect as well. So if I just run telnet, which is a standard tool in Linux for connecting to TCP servers, very good for debugging. And let me just do one more thing. I usually do something like this, because sometimes I close down the window, and if I close down the last window, then the screen process terminates. So I usually do some bash script like this, so I always have one window which I don't touch and which will not be closed down. Okay, so let's see, the port is 2343, And as you can see, we are connected to the server and graded by this 100 connected to the cache 22 server. And these kind of server codes, I'm not really sure if we are going to use it like that, but let's keep it for now. Alright. Let me just cough. Sorry. Okay. So, where to go next? I need to have some functions that take care of the input from the user. So let's begin there. I want to be able to break down these commands into different space separated variables, basically. So let's see, we are running the main loop and then we are running the child loop as soon as we get a connection. So this is all that we have this far. And we are passing this structure around to the different functions. And if we take a look in the H file, the client structure looks like this. So we have the socket, the file descriptor, which represents the connection. And then we have the IP address in regular format, like this kind of format, as a string. And then we have an int16 for keeping the port number. So that is what we are passing around. So what will we do here? We want to grab the input from the user every time this loop iterates. So let's create a string variable, or int8 as I use in this project, and let's call this buff and 256 as size. So this will be the buffer that we read from the socket file descriptor. So let's start there. In order to read from a file descriptor, we use the read system call. And before that, by the way, I want to zero out this variable, like so. And the first argument of read is the file descriptor, which we keep inside of this client structure, and S, I think we called it. And then we read it into buff. And finally, we need to specify the maximum number of bytes to read. And I usually take one less than the size of this variable. Okay, so now we have a command, and the command will look something like this. Select and then the path, so like users, and then we specify the actual leaf. So something like if we have a folder for the users, we might have a leaf for the different usernames. So this can be one command, and then we will have commands like create, just to create one of these nodes, like this. And in order to grab the data, we use select for that, right? But in order to alter and add data, we use insert, and we specify the path, like this, and then we will just put the value right here without any quotes or anything. So basically what I want to do is I want to have a function, or several functions actually, but I want to break it down so we get this command inside of one variable. We get this possible second token in a different variable, and then this third in the third variable, and then we will call that specific function based on this command. So basically we will have a structure which looks something like I don't know what to call it yet, but let's say ABC, and then we will have a function pointer as the first argument. So let's say we have a function for the select, and then we have a string for it as well. So the function we are going to write will map this to a specific function and run it and send all these as arguments. Then it will be very easy to add these commands, and it will also be very easy in the future to be able to create plugins and more functionality. Alright, so let's see how we are going to do this. I think we can do it right inside of this child loop. So how do we separate it in these kinds of tokens? I don't want to use any library calls or similar, so let's code this ourselves. So basically we will set this let's create a by the way, before I forget, the read function will probably need a casting for this one. No, not int8. It should be a char when we call this function. This one is okay, and this one is okay. Alright, so let's create a char pointer. This int8 is actually a char. It's an 8-bit integer. So let's see. We will do something like, I think a for loop would be the easiest. So in the beginning we will set p equal to buff, and we will loop as long as, and then we will have a couple of conditions right here, and every iteration we will just increase this pointer by 1. Okay, so what are the different conditions? Well, we want p to be, or the thing that p is pointing to, we want it to be non-zero, right? Because when we reach the 0, we will well, the string will be done, so to speak. And we also need to keep track that we don't overflow this if they send a very long command. we are limiting it with this one, but I would feel more comfortable if we had a counter as well. So let's see. We can set this to the int16 version of string length, and we pass the char version of buff. So there's a lot of these typecasts because I decided to use this standard, but it's not too troublesome, because if we forget, the compiler will yell at us. Okay, so let's see. N contains the number of characters, and perhaps we should do something like, if n is bigger than 254, we set n to 254. So we are using both the we are using two different ways of protecting ourselves. Okay, so let's say we decrement the n each iteration, which means that n should be positive. And let's do like this. So what else? We should also stop if I think we put it like this. We will also stop if p is equal to the space, because remember, this is how it looks. So we will go character by character until we find a space, or until we are at the end of this string. We can also check for p equal to new line, and perhaps we should check for these annoying Windows style new lines as well, or carriage returns or whatever. Let's see. Okay, so p equals buff. We check that p is positive, that n is positive, and that p is not this or this or this. So basically, when this loop is done, we don't even need a body for it actually. When this is done, we have a couple of different scenarios. Either p is equal to 0, and what do we do then? That means that the command, let's see, it means that the command is filling out the whole buffer. So we have sent something like just insert. Let's create a couple of variables to hold the results as well. So we will have a command, and we will have a folder, which is the second argument, and then we will possibly have additional arguments. Okay, so when we reach this stage, we can set the command equal to buff, because that's the only thing that we have inside of buff. And what else? If it's equal to space, then we will need to copy this. So the easiest way is to take this space and replace it with a 0 byte, because then we can just do a string copy on the buff in order to get the thing we want. So let's set p equal to 0, and then we will need let's see, we need an additional buffer. So maybe we shouldn't use pointers for these ones. Let's do this instead. 2, 5, 6. 2, 5, 6. 2, 5, 6. Like so. Or maybe, let's see. Well, let's do this for now. So in case, let's change this so we don't forget. So in this case we want to copy, and we want to copy into the char version of CMD, and we will copy the char version of buff, and the maximum number of characters is 255. And before we do that, we will also zero out. Let's do that before the conditionals, by the way. So let's zero out CMD 256. Let's zero out folder 256, and let's zero out args 256. Like so. And now my cat will try to intrude. Never mind. Okay, so we have zeroed out the variables. We have copied the command in case of when we have issued just the command. And in this case, we will set this to 0, and then we will do the same as here. We'll copy to the folder from the buff maximum 255. Yeah. And then we are done. We also need to sanitize these by removing those new lines and stuff. Perhaps we should have done that from the beginning, but let's hold off on that for a little bit. Okay, so we have our two conditions. We also need to, well, basically we can do the same as here when we encounter one of the new lines, right? We want to overwrite it with a 0 and then copy the stuff before that. So let's make this if statement a little bit bigger. So if p equals this, and if p equals this, And finally, if p equals this. Okay, so we kill 3 birds with 1 stone. Right. Let's put it there instead. Okay. So, is there anything else we need to consider? Yeah, this one. When this reaches 0, it should be treated the same way as this first condition. So if p is equal to 0, or if n is equal to 0, then we should do this, right? If p, this should be an or, because it's equal to this, or this, or this, then we do this. Okay, good. Okay, so now we have the command. Now we want to continue by doing the same again, basically. We will simply loop over in the same way. So it will be a little bit undry at this stage, but it's better to just make it work, and then we can use time to make it more good looking code if we want to. So let's just completely shamelessly copy paste this and just alter a couple of things. So we will not zero out these structures again. Okay, so p will be equal to what actually? What is p equal to at the moment? It is pointing at this, right? The space. Or it is at the end. Let's go to sometimes those kind of solutions are the best to start with, at least. So if this happens, then we are done and we can go to done. Else we do this, and then we continue along with the second iteration. Okay, so then we can set buff. We can almost leave p as it is. We only need to increase it by 1. Let me have one of these. Let's copy them all, so I have them available. It's easier to grasp how the things will look. So currently we have the p pointing towards this space, and we want it to start by pointing right here. So we increase it by 1, and then we do a loop again, and we check if we should reset the n too, right? How should we do with the n? No, we can leave it as it is, I think. Let's do that for now. Okay, so we check if p is not 0, if p is not space, if p is not this or this. Right. And then we do this check again. only this time we will copy to not the CMD but into the folder. And by the way, this shouldn't be folder, this should be command. Am I right? I think I'm right. Okay, so we copy it into the folder, but we can't copy the entirety of buff any longer. We need to have a pointer instead. Let's name this F, because it will point towards the folder's beginning. So P equals buff. Let's see, which one is it? Here. So P++ and then F equals P. So basically the F is pointing towards the beginning of this second argument, which means when we do the actual copying, we will be copying it from F as a starting point with buff. And same here, F, like so. And we'll also have the go to done. And then all we are left with is the last argument. So let's see, in this case we have spaces and stuff. And we copy into folder from F. So let me see. So we start here and then we copy this stuff. So P is pointing towards this, either this or P is pointing toward the end of the string or of the buffer. So if we are pointing towards the end, we should have jumped to done, right? No, we do a check. Yeah, we do it here. So the only thing we will need to consider, let's see, here it is. The only thing we need to consider is that we are here, and if we jump one more step to the right, we should just be able to copy the end of this, basically. Am I thinking correctly? We copy into the folder, and in here we are. Well, let's try it out. It's a very big function with a lot of moving parts, so it's a little bit tricky to keep track of everything. We'll probably have to troubleshoot a little bit, but when we create all of these kinds of functions ourselves, we have a much greater possibility to optimize it. If we just use something off the shelf, we don't. So I think this is necessary if we're going to beat Redis. Alright, let's increase P and if p is positive, what will we do? Then we will do a string copy into the char version of args. And what do we want to copy? We want to copy the char version of p. And what will be the maximum? Well, we can still use 255 since this is a different different string variable. Why is this here? Okay, so now this contains the arguments, and possibly it also contains the new lines and stuff. So let's deal with that now. So if p is positive, then we do this copying. Then we can point p towards our args. We can do it like this. We set p to args and we loop as long as p is positive. As long as p is positive, and p is not equal to a new line, and as long as p is not equal to this. Let me just check this first one so I didn't mix up the logic. If p is positive and n is positive and p is not equal to, because we're going to stop the loop, right? So else if p is equal to this, or this, or this, and then it'll be the same right here, because p should be positive, this should be positive, and this and this and this should not be any of those, like so. If p and n are, if p or n are negative, we do that. Else if yes. Okay, that looks right. And now p equals to args. We will loop as long as p is positive and p is like so. And what will we do each iteration? We will simply do p plus plus. Like so. And then we can just set p to 0, right? Because if it's already 0, this won't mess up anything. And if it's one of those, we want them to be 0. So this should fix our new line problem, I think. Okay, so now we have our variables. Let's print them out one by one and see if, let's actually print them to the user connecting with the client. So we will print command. Like this. And this is the command. And this is the folder. And this is the potential arguments. I have a feeling that we have missed something and this is gonna segfault so badly, but well, there's only one way to find out. So then we can return. Okay. Well, let's see what happens. And I have been disconnected. So I basically just use screen -RUD, and then I have a couple of different screens. If I only have one, I don't need to specify this number, but now I need that. So 14 is the one, right? Yeah. Let's see what happens. Okay, not as much errors as I anticipated. Oh, the ABC, I never removed that. So let's go to this one. And then I space down a little bit before I clear the screen. And why do I do that? Because when I compile and get a lot of errors, then I want to be able to scroll up and easily find the beginning of this command. Okay, what does it say? Okay. Where was that? So this looks weird. And this same problem here. But I did see something else. What was it? A colon there. 82. 82. There. It should look like this, right? Basically, when you end a for loop or similar commands with a semicolon, then it basically means that you don't want to have a body to that loop, because all I need for this is a different looping, so to speak. Loop until I get to the point I want to be, and then I do this once. Alright, let's try again. Oh, we get more errors, not less. Well. Oh, it's a lot. Expected. Okay, this error is probably producing most of the other ones. 34. 34. This one. Okay, we have this condition and this condition and this and this. and this. Okay, this shouldn't be here, right? So then we should probably do the same somewhere around here, and hopefully most of these errors will disappear. Yes, but still I did something similar. No, it's still complaining about 82. Still complaining about 82. It's my unlucky number 82. Let's see. Okay, so we have a for loop. Then we have a couple of conditions. Well, we don't really need these parentheses. So we check for this and this and this, and then we don't need that, but we do, however, need this, right? Let's try it again. Okay, now we're getting somewhere. Warning, this for clause does not guard this statement, but the latter is misleadingly indented. It's actually complaining about my indentations. That's quite funny, actually. So for p equals this, and we check that this is true, that this is true, and okay, I kind of agree with GCC. This should be there instead. It was quite sensible after all. And only one left. String copy output may be truncated. Oh, I dislike this error so much, or warning. Because I have knowledge about my variables. And I don't think that GCC should annoy me about that. Let's actually remove this one. I always forget how to do that. Let's see. Need to go into my OOP. No. And I think I have something like this in my Lambda code. Right, here it is. So let's go into our H file and somewhere at the top we put in this, and which error or warning rather do we want to suppress. This one, because it's not complaining or warning me that I am causing a buffer overflow. No. it's complaining that I am not copying as much data as I should have. So it's the other way around, and I don't really care for that. So then we can add this pragma. And we need to pop as well, and let's do that inside of this C file at the bottom. There we go. And then we do the make clean, and now we should hopefully don't get that annoying error. Great. Okay, let's try this. Do you think it will work on the first try? Let's see. So I will connect to localhost, and what port did we use? 12049. 12049. Here we go. And let's say we will run the command create users. Did we cause a loop perhaps? It's not crashing it. Oh, wrong window. Okay, so how do we debug this one? I think we can start by doing an ltrace that follows forks. This will show us all the library calls. So let's telnet into this and issue the same command as before. Probably we won't see much if the actual looping is causing this. Let's see. dprintf broken pipe, child exited. Looks like it did crash after all. It runs the string length on nothing. Why on nothing? We read without return. We have a dprintf. This is probably the welcome message, I would think. But it's writing towards 4 here. And here it's writing to 3. Okay. Let's look through the code a little bit. Where were we? Right, child loop, client CLI, and we zero out the buff. We read from this file descriptor into the buff with this size, and n equals the int16 value of string length on the buff. This should be okay. I would think so. Perhaps there's something wrong with this structure. What if we would just try to print something there? So if we do write client S, and a new line, and this would be 4 bytes. And then we will exit 0. So let's compile it again, and we can run it the usual way first. Let's connect, and we type something, and we do not get a response. We do not get a response. So, did we do something wrong with that? With that client structure. So let's see. This is inside of the main loop. We accept the connection. We figure out the port and the IP. What then? We allocate the client structure, size of struct as client with 0. Everything. We set the S to S. And what is S? S is S2 we get from accept. That is the child's file descriptor. But the S, that is the main process. So that's probably it then. Let's save this. And well, it's not the only thing actually, because we shouldn't crash, but at least we're one step closer. Let's remove this for now. And let's compile. Where are we? Is this the wrong? Yeah, it's the wrong window. There we are. So let's connect to this one, and let's issue the command create /users. Okay, so the command is create, the folder is users, and the argument's empty. Beautiful. And what happens if we issue only something like help? The command, it's still help, but there's a new line with a folder. Okay, we need to remember that. And if we do a longer command, so insert users this, and then some kind of value. Let's add some Shakespeare to the mix. So the command is insert, the folder is this, and the arguments are those. That's how it's done, ladies and gentlemen. Now I think is an excellent time for the break. We are halfway through, and yeah, let's do the break now, and let's return in 20 minutes. See you then. Okay, everybody, we are back. Yes, Arnab, let's take a couple of questions. Would you select one? I haven't been following the chat because of the coding, so you can pick one. Well, the best way to learn, I think, in order to really learn, so you become really good at coding, you need to create a project of your own, and it needs to be a project which matters to you. So let's say you are interested in football, for example. Perhaps you choose to create like a program or like a game where you manage a football team. Or if you are interested in video games, perhaps you could create some kind of an editor or some kind of calculator which helps you to plan your armies in more effective ways. Or because if you combine the coding with an interest of yours, then you will be passionate about that project and you will learn double the amount you would have otherwise. Because I tried to learn programming a couple of times, and I learned a couple of commands and stuff, and I did a couple of examples, but it never turned out to anything. But then I combined it with other things, and I created projects that really mattered to me, and then it was a whole different subject. So that is my I don't know, my idea when it comes to that kind of stuff. Let's see. Should we not close the copies of socket file descriptors that the child process receives in the child loop? No, we should not close it in the child loop, because the child loop runs once every time we get a command, and during a connection you should be able to issue multiple commands, right? So let me show you what I mean when we actually should close the socket. Because if we look at this code in the main loop, so here is a fork. So this is where the child process begins. And what do we do in it? Well, we print out this welcome message. We set the variable continuation to true, and then we loop, the child loop. And as long as continuation is true, we keep reading commands from the user. When a continuation is set to false, like when the user issues the quit command or something like that, then we break out the loop and then we close the socket, right? Alright. Do you have any additional questions? No, the code is currently not available on any repo like that. It's like this actually. I always want all my videos to be free and for all to access, but I still have to earn a living. So what I plan to do is create a premium feature where you can donate because you like the video in question, and if you do, you do get a lot of perks. So you get like access to code, and you get a lot of different other things. So that is my basic thoughts on that. I hope you think that is okay. I am currently developing a website. Perhaps I can show perhaps I can show a part of it to you so you see what I mean. I don't want to show the link though, because it's not done right. Let's see. So I'm in the middle of developing. It might not look exactly like this when I'm done. Okay, let's reload. So basically, it will be something like this. The videos will be free and available on YouTube as usual. But if you watch a specific video and you think it's a good video, it's a video that you think is worth paying for, and you learn something from that video, then you can voluntarily go into this page and you can donate like $19 for that specific episode. And when you do, you get access to the code and stuff like that. I have a couple of different things as well planned. And we will also have a high score list with the biggest donators and stuff like that. So that is what I plan on doing. And do we have any more? Any more questions? Hello, Triumph. Okay. But I haven't released that website yet. I'm still in the middle of the developing. But if you do want to contribute, there is a way. You can become a member. And that is actually live right now. You see that little blue star by the name of Arnab. That means that he is a paying member. And then you get a lot of perks as well. So if you watch a video or you go into my main page, then you can click on the Become a Member tab. Hello, Big Master. Welcome to the stream. I can show you real quick that as well. So if we go into my main page, youtube.com, and then it's @ and Dr. Jonas-Birch. So there, become a member, and I have it in Swedish, so that's why it looks different. But if you click that, then you will see the different levels and what you get access to for the different things. But it's basically not. Its focus is that you can contribute if you like to. So that's the main idea, and then you get some additional perks as well. But I think the main thing should be that you contribute because you want to, because you like the material and so forth. Angel is around, I think. I saw him in the chat before. Yeah, he was present earlier. However, we decided to part ways. He's no longer moderator, but we are on good terms. So hello, DevBytes. Welcome to the stream. There you are, Angel. Hello, my friend. And hello, Maglintala. Welcome to the stream. Probably didn't pronounce your name correctly, but you have to forgive me. And hello to Rajesh as well. Welcome to the stream. A time machine. Well, we could probably create a tool like the Apple time machine, but an actual time machine? Well, let's put it like this. If humanity ever figures out how to code a time machine, it will most definitely be written in C. Alright, enough of the questions. If you have any additional questions, or if you come to think about anything while I'm coding, just ask them in the chat, and we will I will answer them when we pause the coding. I'll try to be better to check out the chat every now and then. Well, Arnav, there is most definitely a craze for C++ and Rust, but I still don't think a time machine will be written in C++. We need a language like C for that kind of... Well, C put us on the moon, right? And If we would have tried doing the same thing in C++, it would probably have crashed halfway to the moon. I'm just kidding. C++ is a wonderful language as well. Alright, let's continue with the code, shall we? So, we are able to handle the user inputs with some small bugs. We still haven't fixed the new line problem, and I need to reconnect. And 14, I think. Right. Because where was it? Some command that we issued had problem with a new line. Which was it? Help folder args. Let's check the code. Because we did check and alter the new lines for the last argument, and I think we did the same for the first, but what about the second? So where does the second start? It's right here. So we point towards the space, and then we increase by 1, so we start here. Then we run through this. So let's say we get a new line right here. So then we break out of the loop, and this condition should not be valid, but this. One of these should hit, right? And what do? We just copy into folder from F. And where does P point at this point? It points towards the new line in the buffer. Now we do have a P equals 0. And we do have this here as well. And here we are inside of the args. I think I want to test this again though. Let's just connect to the server and issue a couple of commands. So first let's just do something like this. So it prints the help and it prints folder and a new line. Why does it print an extra new line on the folder when we just issue one command? Let's see. So we go through all of this and we copy to the command, and what happens then? Then we go to this next step. Perhaps we should just do an if check at this point. Something like if P let's see. So in this case we have gone through the first, and if p is negative, then we are done, right? And then all our other variables should just be empty, I think. Let's see if this changes anything. So if I issue the command of help, okay, now it looks better. And this spaces right here, that's just a tab, so that's nothing to worry about. And if we issue two commands, so we do create and a folder, okay, now I messed that up instead. Okay, yeah, I can't go to done. Let's see, because P is pointing towards the buffer, and if any of these are true, we set P to 0, then we copy the command, and if P is 0, well, of course it is 0. Let's do P plus 1 instead, because I want to know if the buffer has ended, you know. This one. Alright. Let's do this and this. And we need to run the program. /22. And issue a command, help. Okay, we're back here again. So how are we going to check that there's no more command? Well, we can, let's see, if P is not equal to a space, then there's no more command, right? If P is not equal to a space, then we are done. Let's try that. Okay, that looks right. What if we were to try to create a folder? No, we messed it up again. if this is equal to space, then we should go, and it's not, because P or N equals, okay, we do have this condition. And let's see. We copy the command. P is equal to this, or this, or this. Then what do we do? P is not equal to this. Well, it's no longer equal to that. Maybe we should break out this into two different things instead. So if we were to do another else if, where we check for these conditions, so if we encounter this new line stuff, what do we do? Then we set P equal to 0. We do the string copy. And then we are done, right? So this should be another else if. Oh, now my cat is on the keyboard. Come on, Alex, look. Sorry, he jumped onto the keyboard. Let's see. Where were we? Yeah, else if, okay. What did I copy over this now? What did we check for? Space. It's just space left, right? So else if this is equal to space, okay, so if it's a space, this we can remove. We just put a 0 instead, and then we string copy this stuff. Okay, so now it should work, I think. Okay. All those brackets. Else if, and we have this, and we check for this, or this, and then we have that. What is this? Let's see. I must have accidentally copied over this code. So this if statement, and then we have this. Do we end this? Yes, we do. Okay, let's try this then. No? 48. What is this? If P, else if this, else if this, okay. There we go. So we issue the command help, and it works. We issue the command create users, and it works. And then we do the insert users and this data. Okay, now it looks the way I intended it to look. Good. So what's the next step then? We need to figure out which function to call. So let's create something in the H file which we'll call a, what should we call it? A function handler, command handler perhaps. And how should that look like? Well, it should be a structure containing, let's see, let's begin by defining the function pointer. So that has a rather weird syntax. I think it's like this. So we put the name right here, and then maybe you should put the return type before this. And then you add to it the signature, the different parameters of the function. And what parameters should we have? Well, it should basically be 3 8-bit pointers. So we should have int 8 star, int 8 star, int 8 star. So this is basically one for each argument. This is the command, this is the folder, and this is the arguments. And what shall we call this thing? This is a connect back. It's a let's just call them callback. Like so. And then we need a structure as well. So the structure we call a command handler. And we basically just need two different variables in here. We need an int8 pointer, which is the string representation of the command. So let's call this command. And then we will have the callback function. So I should only be able to do something like callback. Let's call this handler here. And I don't think I should include the star, since I have the one here. Like so, and then we create a type definition as well. So we type def struct s command handler, and we will call it command handler with capitalized letters, like so. And then we will just create a list, basically. So let's do struct, and no, not struct, we have a better name for it. Let's do command handler handlers. So then we will have a couple of these, one per command. Let's begin by just doing something like hello. And if they issue the command hello, then we will say hello back. So I think we perhaps need to typecast this int8 star. And then we need a function as well. So let's say handle hello. I think this is the correct syntax. I don't use this very often. Alright, and let's create that function as well. So void, no, not void, it should return an int32, and it's handle hello. And by the way, perhaps we don't really need to include the command, because we only need that to find the right function, and that we have already done if we call the function, right? So the only thing we need to have as arguments is two things. It's the folder, and it's the possible third argument. No, we do need one more thing actually. Can you figure out what? One thing that we want to pass to every function, basically. That's right. We need the, let's jump down a little bit. We need the client, right? if we don't have that, will not be able to respond and stuff. And let's update the signature as well. So we will have a client, and where does the client get? It's down here. We need to think about the order of things. So let's move this whole stuff so it's underneath here. Alright. So here we have the arguments, and then we can just, well, this is a temporary thing, so let's just do a dprintf on the socket file descriptor, where we reply back hello, and let's put the argument here as well. Then we return 0. Yeah, let's do it like this. Okay, so now we have a function. We need a helper function which basically looks through these different handlers and maps. So we give it the string representation, and we get back this address to the function. So that is the next step to do. That should be quite easy to write. So we will return a, let's see, what did we call that? A callback. And that is a pointer by definition, I think. So callback, and what should we name this? Let's just do get command, and we send an int 8 command. And we should just search through this thing. We need to make this this should be an array. Okay. So let's just iterate through that array. I'm just thinking we kind of need to know the size of that one. Let's do something temporary. Size of handlers. I think it might be possible to do that, right? So this is called getCMD. Where do we have our main? Here. So we run getCMD with something, hello, and we return 0. I just want to see what size of returns in this case. This one. Okay. Handle hello. What did I name it? Wasn't it handle hello? Let's see. Okay, I never wrote that function. Let's just do it signature then. So we will have an int32 handle hello, and it's gonna take a client, but didn't I write that function? Yeah, I did. Handle, okay, is it because it's below? Let's do a function declaration. So we have int32 handle hello with a client and an int8 star int8 star, like so. Okay, that disappeared. Format expects argument of type int, but argument 2 has type long int. Okay, it's long. All those 64-bit CPUs, right? So it should be CU, right? Let's put a new line as well. And we need to, where is it? 202. This should be an int8 star. Alright. So let's run this thing. 16. So we have this stuff and this stuff. What if we were to have two of those? Will it still calculate it correctly? So now we should get 32, right? Okay. Alright, so that makes things a lot easier actually. Otherwise we would have be forced to like have a define or something like that, which contains the number of well, number of things in that array. But now we can calculate it quite easily. So let's remove this. And what should this function do? Let's create a callback, which we call CB. And let's do an int 16 of n. And then we do for n equals 0. Let's do it in 2 steps. Okay, so we have this and we need something. What should we call it? Array length. And array length should be size of handlers, and we should simply divide it by 16 then. This parenthesis is not necessary, it's just my own convention. So, then maybe we should do some kind of check first, like if size of handlers is less than 16, return 0. Okay, so we set n to 0, we iterate as long as 0 is less than rlen n++, and in each iteration we do a simple string compare of the char version of CMD and the char version of handlers and dot, and what did we call them? We have CMD and we have handler. So this should be CMD. So if those are equal, what do? Well, we do this. We set CB. Okay, we probably need those as well. We set CB equal to handlers and handler. And let's initialize it first. So CB equals 0. Like this. And after this loop, we just check if CB is true. No, we don't even need to do that. If we just do return CB, it will return 0 if it is 0, so that's really not a problem. No, not CMD handler. Call. What should it be? It should be a pointer, right? So X. Then we do it again. This time we don't get a match. Okay, let's try this. And then I think we need to call it a night actually. But let's make this work first. Alright, let's see. We'll recompile. Oh, what is this? We basically added 3 lines of code or something. The handler has no member. Okay, that's just a typo. And what is this? Probably all these errors originate from the same stupid thing. Let's see. Handler with a double H. Where is that? Handler, handler, handler. There. And we... Okay, I never finished this one. Okay, we need to break, so we don't search this unnecessarily. This is part of this. Okay, that explains all the errors. Okay, only 2 left. So what does it say? Assignment to blah 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 blah. Incompatible pointer type. So CB equals handlers and handler. And what kind of structure is handler then? Handler is a callback. Maybe we should put the star there after all. Okay, maybe we did it backwards. Let's remove the stars instead. Okay, now it's compiled. Great, let's run this thing. And it works accordingly. So first we do a check for hello. Does we have a function that can be discovered by that string? And yes, we found a match with this address. And then we tried to search for blah blah blah, and we got nil back, which is the same as 0 in Britain, perhaps. Alright, now my back is killing me a little bit, so I think this is good for one session, don't you think? We have managed to get a lot of work done, and everything has worked pretty well, I think. Yeah. Thank you, Arnav. And awesome job with the moderation and stuff. So we will do a new open for all free stream like this. I'm not sure when yet. It might be next Friday, but it could be the week after as well. We'll see. But thanks everyone for watching, and have a good day.